So for the homework, let's go and close the solution right now. Should I post this kind of garbage code on the samples web page? I'll post it, regardless to what junk was in there. So file open. I will open the solution, right? And I will go back to our. I guess it's on F drive right here. Projects, stack demo, great, that's the one. All right, stack demo solution, so open that. Okay, so going back to the stack demo solution, let's quickly observe what we have in this prototype related to the homework. So perhaps it's a good point to start just looking at the main function. So the main function says, I want to be able to create a stack object. I want to be able to push something on it, and clearly for the compiler to know what this is, we need to include the header file. The header file example is right here, right? So we're looking at it, and so it says, so currently in this particular prototype, we have a constructor of our object, we have a reset function, we have push, and we have a pop. And we have those two versions of push and pop, which we're about to discuss. So anyway, we discussed the situation where you can push multiple times, you may want to pop multiple times, and things like that. So the important thing to remember also is that we said to be able to do something like this, and this is why we use const, this is why we use const when declaring an array of integers of the size, because this is not a dynamically allocated array, we have to use a constant, right? We want to say, 10, but instead of hard-coded 10, which is kind of strange looking, we wanted to give it a name. So we said constant int, and to be able to use initializer inside the class declaration, it also had to be declared static. So we have an array of 10 integers, but we also have a stack pointer, so that stack pointer constantly refers to a particular element, which supposedly is the top of our stack. So the next challenge in this homework is to be able to push an array of integers on the stack. And also another challenge is that how about if, so this is an implementation file. Let's just quickly take a look at the implementation file. Let's see. Here's our constructor. So let's display this side by side. The implementation of the constructor right here is simply setting the stack pointer to 0. Make sure that we're pointing to the first initial element in our array. Then we have implemented this push and this pop by saying, trying to push if stack pointer is outgrown the initial storage size. So basically 10 or greater, because this was defined as 10, then stack is full, do nothing. Otherwise, go ahead and store the element in this array, which now belongs to our object. Use stack pointer, and immediately increment the stack pointer so that you're ready for the next push. On the opposite side of things, we have a pop, and it says, okay, if stack pointer is 0, it means that nobody ever called this function, and the stack pointer was never incremented. Because as soon as you push, it becomes non-zero. It will only grow. So this suggests that in this case, the stack is empty, and trying to attempt to pop from an empty stack is illegal by design, and we're trying to tell the user. Otherwise, we decrement the pointer and happily return the value from that memory. right? So does this notation now appears to be a little bit more friendly in terms of understanding what really is happening here? Because again, the storage is just an address in memory, and this is an indicator of which element in that memory you try to access. And to begin with, we remember that storage was simply an array which was never initialized, right? So, but we really don't care. So it contains 10 integers in memory which initially contain garbage. And I guess I can go back to this part of the assignment where it says this is a copy and paste from the assignment document itself. And it says, why don't you add two functions, push and pop, such that in our main function what we can do is this: stack push an array of integers of some sort, and essentially we have to pass the size of an array. So let's create an array first. Integer I array, say 4 elements, and we can even initialize it to be 11, 22, 33, and 44. Okay, how about that? 4 elements in the array, they're all initialized. We say we want to push and store these values on the stack. So we have to specify how many, and we have to pass the array to our stack. The stack, so let me now go here and say the stack says that we will now allow to store arrays in our stack, as long as you specify how many elements you want to store. Let's take a look at the implementation of those two functions. I'm actually going to erase all this and start from scratch, because I think I was showing a student the other day what this all means. We have used in our previous example that you can pass a pointer. You can pass a pointer to a function, and as long as you find a way to provide an address to initialize that pointer, you may very well use it inside your function. So saying int arr, and use like empty square brackets here is the same as using a pointer. This is an archaic way of declaring an array as a parameter. Arrays can be passed as a parameter, but it's exactly the same as this. It is simply that in C programming language, since early days, a lot of people wanted to basically say, well, to this particular function here, I am passing the name of my array to this function, but I want to be reminded in my function that I'm using an array. And so this syntax, it can be, it's the same. It's just basically a little bit of an outdated syntax, which suggests that the two things are exactly the same. You can pass an array and say in your function. So now I comment this out, since this is from our homework assignment. I will use this notation, and I will say that, okay, so you can basically declare an array as unspecified number of elements here, and pass a real array as an argument without square brackets, similar to what we did with pointers, and also require an array size. So in this case, if we want to push, we already have a version of a push, right, which pushes individual numbers. Okay, so maybe I can leverage that and I can say integer index. It almost becomes a routine procedure. So let me save this real quick. Just